question. Let me see. Yes, except for a different molecule. You've been tasked with sulfur hexafluoride. We're going to do selenium hexachloride, a closely related molecule. In this particular one, we've got, so there are 6 chlorines attached to it. Let's see, 6 plus 7 times 6. So 6 valence electrons for selenium, 7 for each chlorine, and there are 6 chlorines. That adds up to 48 electrons. When I draw my Lewis structure, I'm just putting 6 different positions around it. It doesn't have to mirror the shape. Some people would say it does somewhat mirror the shape, but we'll draw the shape again in a minute. And then, let's see, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48. And it actually works out that all of the chlorines, so each chlorine has 8 electrons. 6 times 8 is 48, so there is no pair of electrons on the central atom. Which is great because there is no 7 electron group thing in this course. So it would be hard for there to be a pair of electrons on that central atom. Impossible, in fact, I would say. All right. Now this time, let's see, label. If we did a formal charge analysis, we would see that all of the formal charges in this molecule are 0. Draw the correct shape of the molecule with out and back wedges. Draw all dipoles. Well, we're basically going to do the same picture we did before. Because it's octahedral, it's got 6 electron groups. My out wedges could be a little better there. There we go. And now this time I do have 6 atoms. Like so. Now when I drew the shape here, remember your shapes do not have to have all pairs of electrons. So this is a fine answer. Your Lewis structure does have to have all pairs of electrons and all bonds. Now let's draw dipoles. Chlorine is going to be closer to the top and farther to the right than selenium. So as far as dipoles, all of the dipoles face the outside atom, the chlorine, or point towards it. And as a general rule of thumb, so except for hydrogen, dipole arrows generally point towards the outside atom. And of course, hydrogen, being way over on the periodic table to the left, has a lower electronegativity than all of the nonmetals, all of the covalent bond forming species. So the arrow never points towards the hydrogen. Okay. Let's see, B, draw the correct shape and draw all dipoles. Label each bond angle. All right, I'm just going to write all bond angles are 90 degrees. And that's a perfect 90 degrees. They're all equal to each other. D, what is the electron geometry around the bromine atom? We already said that it's octahedral. Are the bonds in the molecule polar? Yes. Is the overall molecule polar? This one, the answer is no. And that's because all of these dipoles exactly cancel each other. And if there is no pair of electrons on the central atom, all of these dipoles cancel and it will be nonpolar. That is a general trend as well. Okay. Any questions about this one?